Hello and welcome. And today the topic of discussion is heap sort algorithm. So I request you, if you are directly coming to this video, kindly watch Max and Min Heap video. So it will become very easy for you to understand heap sort algorithm. Fine. So let's start with heap sort algorithm. So what is heap sort? Heap sort was implemented by John Williams. Okay, and uses the approach just opposite to selection sort. What is selection sort? In selection sort, in a given array of elements, what we do in a selection sort, in a given array of element, we find minimum and in entire array, we find minimum in entire array and put it at first position. Then we find the next minimum and put it in second position. Then we find the third minimum, we put it in third position. But it is just, since heap sort is opposite to what we do, we find in an array which is the maximum and put it at last position. Then we find next maximum, put it at second last position. So it is just opposite to selection sort. Fine. So heap sort is just opposite to selection sort. Fine. Okay. No, I'll not read all these things. Heap sort is almost complete binary tree, which is already, heap is what? What is heap? It is almost complete binary tree, which I've already explained in my min heap and max heap. What is almost complete binary tree or complete binary tree? A complete, almost complete binary tree or complete binary tree, something like this. First node will come here, second will come here, third will come here, fourth will come here, fifth will come here, sixth cannot come here. First of all, left node will come, this and then this, then this, then this. It's not possible. No, first left child, then right child. For every node, first left child, then right child. For every node, first left child will be completed, then left right childs will be completed. Fine. Okay, so this a complete binary tree or almost complete binary tree? Yes. Is this a complete binary tree or almost complete binary tree? So this heap is almost complete binary tree, or you can say complete binary tree. In some books it is said as complete binary tree, in some books it is said as almost complete binary tree. Fine. Okay, now what is max heap and min heap? We have already discussed what is min heap. When, if you consider any node, then that node should be less than its both the child. Is this less than both the child? Yes. If you consider this node, is this node less than both the child? Yes. If you consider this node, is this node less than both the child? Yes. So this is min heap. Now max heap is just opposite to min heap. You consider any node, it should be greater than its both the child. Fine. Is this node is greater than both the child? Yes. Is this node greater than both the child? Yes. Is this node greater than both the child? Yes. So this is max heap and this is min heap. Fine. So this is max heap and min heap, and you have to keep this particular thing in mind. And in my previous video I have already explained you how to create max heap and min heap. So let's move further and see the algorithm of heapify. That is, what is max, how to heapify, that is how to create max heap and min heap. So this is the algorithm, so which we have already discussed, but my job is to explain you. So you have given an array. Let me put the values in an array which is 6, 14, 3, 26. This is a simple array. 8, 18, 21, 9 and 5. Let me make a tree of this array. 6, 14, 3, 26, 8, 18, 26, 8, 18, 21, then we have 9, then we have 5. Fine. Okay, so we have these, we have created a tree. Now let me change the color of my pen. Now let me explain. Is this a max heap? No, this is not a max heap. So how to do MaxHeapify, which I have already explained you, that if I consider the index, this is first index, this is second index, this is third index, this is fourth, you can match from array, fifth index, sixth index, seventh index, eighth index, ninth index. What I have to do, I have to start from, what I have to do, I have to start from. So let's see the algorithm first. Okay, this is the array. So let's see the algorithm. Suppose 6, 14, 3, 26, 8, 18, 21, 9 and 5. What you did, first of all, your job is to do, your job is to sort this element. So in order to sort this element, what you did, you simply called heap sort. You said heap sort, take this array and sort it. So heap sort said, so see what heap sort said. Heap sort said, instead of coming to me, fine, you came to me, but what I'll do, I'll first call max heap. So this is what, so what this is saying, this function is saying, instead of coming to me, you just go and call build max heap. So what heap sort did, so heap sort, took the entire array which is passed to him and passed the same array to build max heap. So I'll again jump to the new definition of build max heap, and I have given this array. So what I'm doing, what heap sort is saying, so I'll heap sort only when it will be either max heap or min heap. So since I'm considering max heap, so it has called a new function which is called MaxHeap. So what MaxHeap will do, it will calculate the size of heap. So heap size of A is equal to length of A. So what is length of A? 9. So it will become 9. Fine. Okay. So from where I have to start, which I have already explained you, from half. What is length? 9 by 2. And the 9 by 2 floor value is 4. So I will start from 4 till 1. So I will start from 4. This loop will start from 4 to 1. Fine. Okay. Now let's see what I'm doing is what I'm calling. What am I doing is that I'm calling MaxHeapify. See, I'm calling MaxHeapify AI. What is A? The entire array. And what is I? 4. So I'm giving an entire array and 4. So let me make a tree over here. Fine. Okay. So 6, 14, we have 3, 6, 14, we have 3, then we have 26, we have 8, we have 26, we have 8, then we have 18, then we have 21, then we have 9, and then we have 5. Fine. Okay. Now what to do is that I'm calling this MaxHeapify. See, this MaxHeapify will create MaxHeap. Fine. So what it will do, it will find the left and it will find the right. So for I, make left. What is left of I? This. So this will become L and this will become R. So if I tell you the formula is very simple. Suppose I'm asking what will be the left child of 26 and what will be the right child of 26. So you just find out the index of 26, which is 4. So left child of any node is 2i. Left child of any node is 2i. Right child of any node is 2i plus 1. So what is I? 4. So 2 into 4 is what? 8. If you see the 8th index, which is 9, so 8th index has 9. So left child of 26 is 9. You can clearly see, yes, left child of 26 is 9. If I have to find in an array only without having tree, which is the right child of 26, that is, what is the index of 26? 4. 2 into 4 plus 1, which is what? 9. So at 9th index you will find 5. So 5 will be the right child. Yes, exactly right, which is very correct. Fine. So why I'm using 2i and 2i plus 1? Because my array is starting from 1. What if my array is starting from 0? Then left child formula will be 2i plus 1. I'll simply increment, and right child formula will be 2i plus 2. Since we are starting our array from 1, so we'll consider this formula. Fine. Okay. Now, so what is L? How we have calculated L? Hope you understood. So L will be left eye, R will be right eye, which I have put. Now what we'll see is, now let me make the index also. It will become easy for you to understand. This is first index, this is second index, this one is third index, this one is fourth. You can match from array. Fifth index, sixth index, seventh, eighth, and ninth index. Fine. Okay. So what I'll do is I'll check is left is what? Left is representing second index. Left is the index. Is left less than heap size? What is heap size? 9. Yes, condition is true. Is array left, that is value, that is 14 greater than, it's 14. I'm so sorry. What am I doing is everything I'm doing wrong. Okay, fine. Okay, again. Okay, so since we have to start from 4, to 1, so what I'll pass A and I. What is I? 4. So L will I'll start from 4. So what is 4? I will come here. What will become L? This will become L. And what will become R? This will become R. Now I'll check, is L less than heap size? What is L? 8. L is always an index. Is 8? Yes. Is AL? What is AL? Which is 9. What is value over there? 9. Is 9 is greater than AI? What is AI? What is AI 26? No, 9 is not. So this is true, but this is false. So everything is false. Fine. Okay. Now I'll go to the else part, and what will make, I'll make largest to I. What is I? 4th. So which is largest? 26 is largest, which is very true. No, among 26 and 9, which one is largest? 26 is largest. Now I'll come to this part. Is R? What is R? R is representing 9. Is 9 less than heap size? Yes. Is AR? Value of AR is what? 5. Is 5 greater than A largest? What is A largest? 26. No, 5 is not. This is again false. So if this is false, I'll not change largest. Now if I'll see, is largest not equal to I? No. This is again false. Largest is equal to I because I and largest both are at same index, that is at index 4. So if they are both at same index, why will I exchange it? I will not exchange it. Fine. So 26 is at correct it at correct position. So now what will happen? What will happen? Loop will get terminated, though this function will get terminated. Where I'll simply go and decrement. I'll decrement I. So now I will become, first value of I was 4. Now I will become 3. So again I'll call this function. Again I'll call this function A and give I. I is 3. So I will become 3. So what I'll do now, I'll start from what? I'll start from 3. That is this. So what will be L? This will be L, left of I. This will be R, right of I. So L is at 6th index, right is at 7th index. Is L, that is 6, less than heap size? Yes. Is AL? AL, what is AL? 18. Is 18 is greater than AI? 3? Yes. So this is greater. Now both the condition are true. So this condition will become true. So which will be the largest will become L. So among these two elements, which is largest? So I'm making this is largest. So this 18 is largest. Fine. But still we have one element to be considered. Fine. So I'll not move to the else part. I'll again check. Is R less than heap size? Yes, R is 7 and 7 is less than heap size. Heap size is 9. Is AR, what is AR? 21 is greater than A largest, which is largest? 18. Yes, it is greater. So this is also true. This is also true. So the entire condition become true. So largest will become R. So this is not largest now. This is largest. Fine. So and you can clearly see that among these three elements, which is largest? 21 is largest. Now I will check, is largest and I not equal? Yes, largest and I are not equal because I is at index 3, largest is at index 7. So this they are not equal. So what I'll do, I'll exchange AI and A largest. So what will happen? What will happen? 21 will come here, 3 will come here. Fine, okay. And which I already told you, this now again I will call MaxHeapify function with value A and largest, because the one which is largest will become I. So what will happen? See, A largest, what is largest? Largest is at 7. No, this one was largest. So this largest, I'll pass this largest. So I'm again calling A with what is the value of a largest? 7. So again it will come call A7. L will become left I. Is there any left? Is there any left? No, there is no left. And if I have to calculate using this formula, then what will be the value of left? 2 into I, that is 2 into 7. So L will have 14 and right will have 15. Since there is no index of 14 and 15, so condition will become false. False. See this. Is L equal to less than heap size? No, false. If this is false, I'll not execute this. So this entire will become false. Again I'll come, is R less than heap size? No. So again I'll not check this. So this will become false. So is largest and I not equal? No, largest and I are equal because I is also here, largest is also here. Since both are there, so I'll not exchange also and not move inside this if block. Fine. So if I'll not move inside this if block, what will happen? What will actually happen? I'll again move back and decrement value of I from 3 to 2. No, because I will now become 2. So what will happen now? This I will become 2. So I will come here. Fine. Okay. See how we are MaxHeapifying the entire thing. Now what will happen now? Again I'm calling array with I value 2. So I will become 2. Let me rub all this rubbish. Okay. Let me rub all this rubbish. What will happen? So L will have left I. So what is left I? This. Right will become right I. So this will become R. Is L less than heap size? Yes. L is 4 and heap size is 9. Yes, true. Is AL? What is AL? 26. Greater than AI? 14. Yes. This is also true. So the condition become true. I'll move inside and I'll say largest is L. What is L? 26. So 26, that is 4th index. So 4th index is the largest index. No. Again, I'll not move to the else part. Again, I'll say, is R less than heap size? Yes, R is 5, which is less than heap size. What I'll do, I'll compare AR with A largest. What is AR? 8. What is A largest? 26. Is 8 greater than 26? No. This is true, but this is false. So condition become false. So R will not be a largest. And if this is very true, L is the largest. So again, I'll check, is largest not equal to I? Yes, largest and I are not equal because largest is at index 2. Largest is at index 4. I is at index 2. Since they are not equal, so what I'll do, I'll exchange AI and A largest. So when I'll exchange AI and A largest, 14 will come here. and this 26 will come here. Fine, 26 will come here. 26 will come here. So 14 will come here, 26 will come here. Now what will happen? So 26 will come here, this will come here. Now again I'm calling MaxHeapify with A and largest. What is largest? 4. So again I'm calling A with 4 value. This again I'm calling this A with 4 value. Fine. So what will happen now? What will happen? I will come here because I has now become 4. Fine. L will be left eye, R will be right eye. Again, I'll see this. Is this greater than this? No. Is this greater than this? No. Since both are not greater than this, so this condition will become false. So what will happen? I'll execute else part. So largest will be I. So this will be the largest. If this is not greater than this, which will be the largest? This. Now I'll compare this and this with this line. What I'll do? I'll compare this and this. Is this is the largest? Is this is the largest R? No, R is not largest. So this is the largest. Now in if block, I'll check largest and I are not equal. They are equal. I and largest are at same position. So if they are equal, so what I'll not exchange them. If they are equal, why to exchange? And again, I'll not call them. Fine. So till here, my job is done. So till here, till second position, I have done what? MaxHeapify. Is my job over? No. Still one value of I is remaining. So now final value of I will become 1. So again I'm calling a MaxHeapify with A and I is 1. So what will happen? I will become 1. So this I will become here. Fine. Okay. So this I will become here. Now what I'll do? L will become left eye. This will become L. This will become right eye. This will become R. Fine. Okay. Now what I'll do? Is L left and heap size? Yes. L is at second index. Heap size is 9. Yes. This is true. Is AL? This is 26 greater than AI? Yes, this is also true. So again the condition become true. What largest will be L? So this will be, this L will be the largest. Fine. Okay, this will be the largest. Now what I'll do? I'll compare with R. Is R less than heap size? Yes. R is 3. 3 is less than heap size. 9. Very true. Is AR? What is AR? 21. 21 is greater than A largest. 26. Is 21 greater than 26? No. This is false. So if this is false, condition become false. I'll not make largest R because we know that largest is left only. Fine. So what I'll do? Is I and largest not equal? Yes. I is at position 1 and largest is at position 2. Since they are not equal, I'll interchange them. So when I'll interchange them, so 26 will come up and 6 will come down. 26 will come up and 6 will come down, and 6 will come down. Fine. Okay. Now what will happen? Again, see, due to this 6 is my property violated? Yes. Now again I'm calling MaxHeapify with A largest. What is largest? 2. So again I'm calling this MaxHeapify with 2. See this. So what will happen? This I become 2. So this I will become 2. This I will become 2. What I'll do next? Again, L will become left eye. This will be L. This will be right. I'll again compare with both the element. Which is largest? This is largest. What I'll do? I'll exchange both of them. So what will happen? 14 will come here. 6 will come here. So again I'll see. So again, after exchanging, I'll again call A with largest. Which one was largest? This was largest. So this will become I. This position will become I. And again I'll check which one is largest. Since this one is largest, what I'll do? I'll again exchange. So what will happen? 9 will come here and 6 will come here. Fine. Okay. So now this again, this will become I. Now there is no element, so condition will become false. And finally I have reached all the condition of I have taken all the values of I. Now my job is done. So my build MaxHeap has said my task is over. My task is over. So now the current tree which you are getting is MaxHeap. So now let me convert this heap to an array. So what will happen? This entire process, this entire element will be changed like this. First element is now having 26. Next is 14, then 21, then we have 9, then we have 8, then we have 18, then we have 3, then we have 6, and then we have 5. Finally we have this. Now is this a sorted element? No, this is not a sorted element. This is a heap sort. This is not a sorted element. This is a heap sort. So what I'll do next? Now what build MaxHeap will say, my task is over. So it will again go to the heap sort. It will, since heap sort has called build MaxHeap to make a MaxHeap, since MaxHeap has done all its tasks, it will go back to the heap sort and say, sir, you give me a array, raw array, and you ask me for what? Creating a MaxHeap. Your job is done. You asked me to do a MaxHeap. I did it. Now your job is to sort the element. So heap sort will say, yes, it's very good. Thank you so much for giving me a MaxHeap now. So I'll start from what? Length of A. What is length of array? 9. So what will do? It will start from 9 till 2. So what will be the value? 9, 8, 7, 6, 5, 9, 6, 7, 9, 8, 7, 6, 5, 4, 2, 5, 4, 3, 2. So this will be the no the accepted value of I. No, so first I will start from 9. So it will start from 9. What it will do? It will exchange A1 with A9, A9. So when you will exchange A1 with A9, what is actually the procedure? Let me tell you. Then I'll explain you the algorithm. So how to heap sort is that you exchange first element with last element. When you exchange first element with last element, so 5 will come here, 26 will come here and reduce the size so by doing this you can clearly see the largest element of this array is at its position. Hope you are getting. It's just opposite to selection sort. So you will do the same thing in the tree also. So what you will do, you will replace 26 with the last element 5. So what will happen? 5 will come over here and 26 will come here, and then you will reduce the size of heap. So on reducing the size of heap, what will happen? On exchanging, what you will see, by exchanging, this heap MaxHeapify property is violated. You can see that 5 is not the highest element among its both the children. No, it's not greater than from its both the children. What will happen? Again I have to MaxHeapify. From MaxHeapify from where? This first position. So what will happen? You will again call MaxHeap from first position. So this will become I, this will become left, this will become right. Which one is the largest? This one is largest. You will exchange. What will happen? 21 will come here, 5 will come here, again this will become I, again you will compare with 3 element. Which one is largest? This one is largest, because this will become L, this will become R. You will again exchange. What will happen? 18 will come here, and the element which you have exchanged, which was I think 3, whatever it was 3 I think. No, it was not 3, it was 5. Yeah, 5 will come here. Fine, 5 will come here. Fine. Okay, so now again what we did on MaxHeapify, on calling MaxHeapify, my tree is now MaxHeapify. What you will do? So you will again make the changes in array. So first position is now having 21, second position is 14, third is now 18, fourth is 9, then 8, then 5. Sixth position is at 5, 7, 3, then 6. Fine. Okay, now what you will again apply the same procedure. What you will exchange first element with the last element. So when you will exchange, what will happen? 6 will come here, 21 will come here, and you will see that again the 21 will come here, and you will see that second position is having second largest element, second last position is having second largest element. You will again make the same changes in the tree also. So what will happen? You will exchange 21 with 6. What will happen? 6 will come here. Fine, 6 will come here, and what will happen? This 21 will come here, and you will reduce the size by 1. On reducing the size, what you will happen? What you will see that by replacing it 6, MaxHeapify property is violated. What you will do? Again you will call MaxHeapify from where? From first value, that I will become 1. So again you will compare which one is maximum. This one is maximum. You will replace 18 with 6. Fine. Again you will say this is the left child, this one is the right child. Which one is maximum? 6 is maximum. You will not do anything. What will be the changes now? First position will have 18, second is 14, then third will have 6, then you have 9, 8, then 5 and 3. Fine, no issue. Again what you will do? Again you will replace first with second, the last position, which is last 7. So on replacing, here you will get 3, here you will get 18. Fine. Okay, and you can see the third element. Again you will make the same changes. 18 you will replace with what? 18 you will replace with 3. So 3 will come here, 18 will come here, and you will reduce the size. So this is what algorithm is doing. You can see that it's starting from 9. See that it's starting from 9. So the first value of I is 9. So it's exchanging first element with ninth element. Fine. After that it is reducing the size, which we are already doing, and because we have exchanged it, our MaxHeapify property is violated. So again we are calling MaxHeapify with A1. Every time you will call with A1. So first you will replace first element with ninth element, then second last with first element with eighth element, first element with seventh element, then sixth, and again you will call MaxHeapify for value 1. So on doing this step, finally what will happen? Your array will get sorted. So let me run all these things. Now what will happen? What I'll do, 3, 14, 6. So on 3, since 3 is violating the property, which one is maximum? This one is maximum. So what will happen? 14 will come up, 3 will come down. I'll again see which one is maximum. This one is maximum. What will happen? 9 will come up and 3 will come down. So since there is no element after that, what will happen? I'll make the changes in array. 14, second is 9, third is 6, then fourth is 3, fifth is 8, and sixth is 5. Fine. Okay, now you have again make the changes. Again what you will do, exchange first element with last element. So when you will exchange, 5 will come here, 14 will come here. You will reduce the size. You can see that clearly your element are started sorting from backside. Fine. So what you will do, you will in tree also you will replace 14 with 5. So 5 will come here, 14 will come at 6 this position. Fine. And you will reduce the size. Fine. On reducing, what happened, on exchanging, what happened, that the 5 is violating the property of MaxHeap. What you will do, again you will find the maximum. This one is maximum. You will replace 9 with 5. Again you will see which one is maximum. This one is maximum. 8 is maximum. 8 will come up, 5 will come down. Fine. So what happened, what changes took place, 9 will come here, 8 is at second, 6 is at third, fourth position has 3, and fifth position has now 5. Fine. Okay, now what you will do, again you will replace first with last element. So when you will replace first with last element, 5 will come here, 9 will come here. You will reduce the size. So again you do the same thing in tree also. What you do, you will replace 5 with 9. You will reduce the size. On making the changes, is your property is violating? Yes. You will again see the maximum. Which one is maximum? 8 is maximum. So 8 will come here, 5 will come here. Again you will see, since there is only one element, you will compare. Since 5 is at its correct place, you will not do anything. What changes took place? 8 has come here, then 5, then you have 6, and then you have 3. 6 and then 3. Fine. Okay, what you will do, again you will replace first with fourth element, but it is at I, fourth. So what will happen, 8 will come here, 3 will come here, and you will reduce the size. Again what you will do, you will replace 8 with 3. That is in tree also. 3 will come here, 8 will come here. You will reduce the size. On making 3 at upside, what will happen, see, is tree is violating property? Yes. Which one is maximum? 6 is maximum. 6 will come here, 3 will come here. There is no element, you will not do anything. What changes took place? 6 came here, 5 is at its place, same place, 3 came here. Again what you will do, you will replace, you will exchange first with last. So 6 will come here, 3 will come here. You will reduce the size. So you will reduce the size. So what again you will do, 3 will come here, 6 will come here, and you will reduce the size. Fine. Now you are left with only 2 elements. Now you can see that loop will only move to second position only. Is this property is violating? Yes. So 5 will come here, 3 will come here. Fine. Okay, and 5 and 3, and you will reduce the size. So what will happen, you uh, uh, I'm so sorry, 3 and 5, yes, it will exchange, and you will reduce the size until second your entire work is done. Fine. So your entire work is done. So what will happen, 5 will come here, whatever it is, and your job is done, and you will reduce the size, something like this. So sorry, 3 will come here, 5 will come here, and you will reduce the size. So 3 has came to its proper place. Now what happens actually, the entire array which is given to heap sort is sorted now. So hope you understand 3 algorithm. One is of MaxHeapify, which is creating a max heap, and which is just because of build max heap. And in heap sort, after max heap, you are sorting the element by what, you are replacing the first element of max heap with the last element and reducing the size by 1. And again, since we are exchanging the element first with the last element, heap MaxHeapify property is violating. So again you are calling for first position MaxHeapify. So when you will keep on doing this, the element will get sorted from what, last position. Because of that, it is opposite of selection sort. Fine.